Hello everyone and welcome to my channel. Today we're going to talk about how to derive the formula for alpha cubed plus beta cubed. A lot of students struggle with this concept, but trust me, on this channel I'm going to make it enjoyable and interesting for you. Now let's begin. How do we get the exact value or the exact formula for alpha cubed plus beta cubed? If you want to do this, here is what you are going to do. You are going to do this alpha plus beta raised to the power of 3. Okay, we're going to put alpha plus beta inside the bracket and expand it. Now, this strategy works whether it's alpha squared plus beta squared or alpha to the power of 4 plus beta to the power of 4. It's always going to work, right? Put them in bracket and raise them to the power of 3, then expand. When you expand this right now, you are going to get this right here, okay? If you expand alpha plus beta to the power of 3, or in brackets, you are going to get this here, okay? Once you get alpha cubed plus beta cubed from the expansion of this, what do? You make them the subject of the formula. And that whatever remains now becomes the value or the formula for finding alpha cubed plus beta cubed. Now let's expand this and see what we're going to get. So alpha plus beta all cubed means that alpha plus beta is multiplying itself 3 times. This is the second one, and here we have the third one, right? Good. So now let's go ahead and do the expansion. On the left we have alpha plus beta to the power of 3 is equal to, let's multiply. I'm going to multiply the first two, okay? I'll multiply the first two first, then when we're done, we now multiply whatever we get by the third one, okay? Hence, we shall have alpha times alpha, okay, is alpha squared, then alpha times beta is plus alpha beta, then again beta times alpha will give you alpha beta. It doesn't matter whether it's a beta alpha or alpha beta, but since we chose this one to be alpha beta, it's also going to be okay for the next one to be alpha beta for simplicity's sake. Now beta times beta is beta to the power of 2, okay, beta squared. Now we put this in bracket, and remember we're multiplying it by the third bracket, which is alpha plus beta. Okay, let's continue. On our left we have alpha plus beta to the power of 3 is equal to, let's now multiply everything on this bracket or in this bracket with this small one here. Now alpha squared times alpha will give you alpha to the power of 3. Next again, alpha squared times beta will give you plus alpha squared beta. Now let's multiply again. Alpha beta times alpha will give you plus alpha squared beta. Then alpha beta times beta will give you plus alpha beta squared. Okay, now we're done with this. Let's now multiply this one. Alpha beta times alpha will give you alpha squared beta. Then alpha beta again times beta will give you alpha beta squared. You have alpha beta squared. Next up, let's multiply the beta with all we have in the other bracket. Beta squared times alpha will give you alpha beta squared. And lastly, beta squared times beta will give you beta to the power of 3. Okay, now we're done with expansion, right? Let's now collect like terms and see what we can get. Remember, we are looking for this. Like I said, once we get everything here, which is alpha cube plus beta cube. From this expansion, we can make it the subject of the formula and then factorize, or let's say work on the other part, and that becomes the value. Because all we are looking for right now is what's in the form of alpha plus beta and alpha beta. Okay, they must be there together, and then we can say that this is the value of alpha cube plus beta cube. Now let's continue. On our left, we have alpha plus beta to the power of 3 is equal to, now I'm going to pick the alpha cubed and the beta cubed, okay? Bring them together. We found what we're looking for. What are we looking for? Alpha cubed and beta cubed. Let's bring them together. Hence, we have alpha to the power of 3 plus beta to the power of 3, right? We found them. Now, let's go ahead and look at the other ones that are remaining. So let's see if we can collect like terms from here. Right here we have alpha squared beta plus alpha squared beta, right? Okay, we have alpha squared beta 1, alpha squared beta, let me use another pen, alpha squared beta 1, alpha squared beta 2, alpha squared beta 3. Okay, do we have another one here? No. So we can write and say plus 3 alpha squared beta, right? Because we have 3 of our alpha squared beta. This is the first one, this is the second one, and this is the third one, right? So we have 3 alpha squared beta plus, let's now look at the other one. Here we have alpha beta squared. Let me count them to know how many they are. Alpha beta squared 1, alpha beta squared 2, and alpha beta squared 3. It means we also have 3 alpha beta squared, right? Okay, so let's go ahead and add them. Plus 3 alpha beta squared, right? Do we have any other term? No, we only have alpha squared beta and alpha beta squared. Now, we are not done yet. Remember, we have found this thing that we're looking for, but we're not done yet. We have to continue simplifying. If you look at this part right here, let me copy this down. On the left, we have alpha plus beta to the power of 3 is equal to alpha cubed plus beta cubed. Now, 3 is common on both sides, right? We have a 3 here and a 3 here. I can factor out a 3, right? So, what other thing is common on both sides? A 3 is common on both sides. Alpha and beta also appear on both sides, right? We have an alpha here, we have an alpha here, we have a beta here, we have a beta here. So alpha and beta are common on both sides. So I'm going to factor out 3 alpha beta, right? Remember that our formula must be in this form. You must have alpha plus beta and alpha beta, right? And that becomes the value of alpha to the power of 3 plus beta to the power of 3. Okay, let's continue. So now if you factor out the 3, here we have a plus, a 3. Since alpha is common on both sides, we factor out an alpha. Beta is also common on both sides, we also factor out a beta. We open our brackets and copy down whatever remains. Now, we pulled out the 3 from here. We pulled out 1 alpha from here. So if you remove 1 alpha from 2, you have 1 left. So this now becomes alpha. Okay, we pulled out the beta from here. We have no beta remaining. We have our plus. Since the 3 has been removed because we factored it out, right? What we have right here, right now, we also pulled out the alpha, which is here. We have 2 beta here, okay? Beta, we have 2 of them because they are squared. We pulled out 1, which is here. How many remains now? We now have just 1, right? So now, we have actually factored it out. If you multiply this 3 alpha beta by everything inside the bracket, you will get the original expression back. And what's the original expression? All that we have here, okay? If you multiply the 3 by everything inside the bracket, you will get this one back, okay? Now, we have factored it out. So we now have alpha beta and alpha plus beta in totality, okay? And we also have our alpha cube plus beta cube. So we can now make it the subject of the formula. Okay? And whatever we get after making it the subject now becomes its formula. So now I'm going to move the 3 alpha beta multiplied by alpha plus beta to the other side of the equation. So I'll move everything here to the left, okay? So that we isolate alpha cube plus beta cubed. Now let's do that. Here we have alpha plus beta to the power of 3. This right here is a plus, right? This is it's a plus 3 alpha beta. If it comes to this side, it now becomes a minus 3 alpha beta multiplied by alpha plus beta. Okay, this is equal to what? Alpha cubed plus beta cubed. And this is the formula of alpha cubed plus beta cubed. Okay, so whenever your teacher asks you or gives you a quadratic function and asks you to find the exact value of alpha cubed plus beta cubed, you have to do the expansion, and this is the formula that you're going to use to plug in your alpha beta. You plug in your alpha plus beta, you plug in your alpha plus beta. This alpha plus beta is the sum of the roots. The alpha times beta is the product of the roots, and the alpha plus beta again is the sum of the roots. So once you plug them in here, you get the exact value of alpha cubed plus beta cubed. I believe you understood my explanation, and I hope to see you in the next video where I'll be talking more about quadratic or symmetric root of quadratic functions, okay? Or symmetric functions of quadratic roots, as the case might be. So thank you, and see you in the next video. Bye.